Okay, 13. Start to do the problem without recording. Find the z-score of the area under the standard normal curve to its left so that the area is 0.1. So here's my standard normal curve. The mean is 0, standard deviation is 1. And the area to the left is 0.1. That's my phone going off. So this right here is 10%. Right? So I'm going to look on my table and find the closest percent in my table to 10%. And it looks like it's going to be negative 1.28. Okay? Right. And my voicemail. Does that make sense? Sorry about that. Okay. So there's 15. So that's 13. 15. We got the z-score, so the area under the standard normal curve. So that the area to the right is 0.25. So I want this to be 25%. So that means the area to the left is 75%. So again, I'm going to look on my table and see where is the closest percentage to 75. And I've got 74.86, which is 0.67. 0.67 for that guy. Okay. And last 16 on this guy is we want the area to the right is 0.35, 35%. So that would mean this would be 65%. So I'm going to look up on the table 65%. Closest is 65.17, so that would be 0.39 would be my z-score for that. Alright, now the other way to do this is to do inverse normal on your calculator. And those indices are area to the left, the mean, and standard deviation. Alright, we're good on that. Let's go up to 37. Applying the concepts. Mean incubation time of a fertilized chicken egg kept at 105 is in a still incubator is 21 days. Standard deviation of 1. So we got mu is 21 days. Sigma is 1 day. What's the probability that a randomly selected fertilized chicken egg hatches in less than 20 days? Remember, this right here is the days, or I should say, incubation times. And it's in days. So what's the probability that they hatch in less than 20 days? Probability that X is less than 20. And what I would like to see is you can do that on your calculator, but you want to tell me your z-score is 20 minus 21 over 1, which is negative 1. Okay, so since that's negative 1, I already know what that percentage is. But if I take a look at it on my calculator, I can always just find the z-score and do normal CDF on here, and I get approximately, what was it, 15.87%. Okay. There's A. B. What's probably the randomly selected fertilized chicken egg will take over 22 days. Okay, so over 22 days. Mu is 21, sigma is 1 over 22. So probability that X is greater than 22. Well, my z-score is 22 minus 21 over 1. Oh wow, that's 1 over 1, which is 1. So that's going to be by 15.87% as well. C, probability of randomly selected chicken egg, there's 21, sigma is 1, is between 19 and 21. 19 and 21. Well, lo and behold, this is 2 standard deviations away, so our probability that 19 less than x less than 21. Okay, so that's this area here, and this is 2 standard deviations below. Well, if I go 2 standard deviations each way, I know that's 95%, so my scale is really off. So we're going to go half of 95% on there, which is what, 47.5%, if I did that correctly. Yep. Okay, and D. Why would it be unusual for an egg to hatch in less than 18 days? Well, 18 days is 3 standard deviations away, right? And so that's 99.7% of the data is within there. So that means 0.3 is on the outside, so this is half of 0.3. If I was 24, if I was 3 standard deviations each way, this area would be 0.15, and that area would be 0.15. Does that make sense? Okay, because within 3, all of this is 99.7%. All right, I think we're good on that guy.